Good afternoon. We're going to work on this problem today. We have this reaction, which is hydrazine plus dinitrogen tetroxide. It reacts to form nitrogen and water. And all of these are in the gaseous form. So, first thing I want to ask is this reaction balanced? The answer is no, it is not, right? Okay. And what has to be true in order for a reaction to be balanced? That's right. The number of each atom has to be the same on the reagent side as it is on the product side. So currently, how many hydrogens do we have on the reagent side? We have 4 hydrogens. How many oxygens do we have? We have 4 oxygens. And how many nitrogens do we have? We have 4 nitrogens. Now, if we look on the product side, we have 2 hydrogens, we have 1 oxygen, we have 2 nitrogens. So on what is our ratio of hydrogen to oxygen that we have to have in order for this to balance? That's right. The ratio is 2 hydrogens for every 1 oxygen. So right now on the reactant side, we have 4 hydrogens, we have 4 oxygens. So we need to actually double the number of hydrogens. And how can we double the number of hydrogens? That's right. We multiply this by 2. And so if we multiply that by 2, that means that we now have 8 hydrogen, and we have we have 4 nitrogens here and 2 nitrogens here. So we have a total of 6 nitrogens. But now that if we have 8 hydrogens and we have 4 oxygens, how many water molecules does that give us? That's right. That's 4. And now we just have to look and see we have 6 nitrogens altogether. And this is 2 nitrogens. So we have to multiply this by what? That's right, 3. And so now on the reagent side, we have 6 nitrogens. There's 4 plus 2, that's 6 nitrogens. There's 2 times 4, that's 8 hydrogens. And then there's just 4 oxygens. And if we look here, we have 3 times 2, that's going to be 6 nitrogens. 4 times 2, 8 hydrogens. 4 times 1, 4 oxygens. So now our equation is balanced. Now, what we're given is that we start off with 8.0 grams of the hydrazine. And we start off with 96 grams of the dihydrogen tetroxide. And the question is, how much water can we produce? So what's the maximum amount of water? Meaning that as much of this reaction happens as can happen. And if as much of this reaction happens as can happen, then we'll get the maximum amount of water. So if we know the molecular weight of each of these, because in order to be able to define this, we need to know how many moles of each thing that we have, because these coefficients are going to be the number of moles, the mole ratio. Okay. So if we want to know the number of moles of the hydrazine, we do 8.0 grams of hydrazine. And then that's going to be times, and 1 mole of hydrazine divided by 32 grams of hydrazine. And if we do that, our grams of hydrazine and grams of hydrazine cancel out. And what we're left with is 0.25 moles of hydrazine. And then let's do the same thing for our dinitrogen tetroxide. So it's 96 grams of dinitrogen tetroxide times 1 mole of dinitrogen tetroxide divided by 96 grams of dinitrogen tetroxide. So those cancel. So we're left with 1 mole of dinitrogen tetroxide. So our question is, which of these is the limiting reagent? That's right. The 0.025 moles of of the hydrazine will be used up before this full mole of the dinitrogen tetroxide. So if that's the case, we know that this is our limiting reagent. And now all we have to do is say, well, how many moles of water will be generated from if we use up all of the hydrazine? So let's look at the ratio. We know that we have 0.25 moles of hydrazine. And then we multiply that times our ratio, which is 4 moles of water for every 2 moles of hydrazine. So the moles of hydrazine will cancel out, and we will have 0.50 moles of water. And so in order to find out, because they're asking for the mass of water, so they want grams of water. So what we do is we say, how many grams of water is in 1 mole? Well, water is made up of 2 hydrogens and 1 oxygen. Oxygen has a molecular weight of 16 grams per mole, and hydrogen has a molecular weight of 1.0 grams per mole. And so, if we were going to get the full molecular weight of water, we would multiply this times 2, and that would give us 18 grams per mole. So if we multiply that, we'd have 18 grams of water over 1 mole of water. And those cancel out. And what that's left with is 9.0 grams of water. Any questions?